In this repair video, I desolder some LEDs. To resolder them elsewhere, I find a cracked component and I used the wrong MOSFET. This is a Samsung television which doesn't want to start. A red light is blinking when I press buttons on the remote control, but that's about it. Let's open it up. While disassembling devices, I like to make a rough sketch of the device and stick all screws I remove to it with sticky tape and number them sequentially. This makes reassembly a lot easier and no screws will end up in the wrong hole. This TV seems to be quite repair friendly because opening it up was just a matter of removing 17 screws and lifting off the back. Thanks, Samsung. The backlight of these TVs should light up when we disconnect the logic board and apply power. This one doesn't, so there is something wrong with either the power supply board or the backlights themselves. Samsung, in their infinite wisdom, printed convenient little diagrams on the PCB with voltages that should be on the output connectors. Let's measure those. Well, that's close enough. Let's measure the diodes on the board. When putting the multimeter in diode mode, they should read about 0.5 volts in one direction and OL when we switch the probes. I measured all the diodes on the board and they are all fine. This resistor is happy as well. And all the capacitors are also measuring okay. I reconnected the power board to the TV, connected the mains and measured some voltages off camera. I probably touched both pins of the MOSFET, which turned out to be power and ground, and created a short circuit. Now the MOSFET is shorted and the fuse is blown, so let's replace those first to continue our troubleshooting. I found this MOSFET on one of the boards left from repairing some Dell monitors for this channel, and the specifications of that MOSFET are very close to the specifications of the shorted MOSFET here, so I'll use that one.
So, put in a new MOSFET.
As you can see, I'm very proud of my work soldering in a new fuse and MOSFET, but not for long.
Let's see what it does.
Well, at least we now have a nice thumbnail for the video. While inspecting the board a little more, I found this component here, which turns out to be a thermistor, a resistor whose value depends on its temperature, and it is clearly cracked. Now I am not sure if that happened during the short I created, but maybe that was the original fault and the TV didn't want to start because it thought it was overheating. We need to replace it anyway. Let's order the replacement parts. So that's 5 fuses, 5 MOSFETs and 10 thermistors, so I get 5 more chances to blow them up. Good. And here they are, all the way from China within about a week. Amazing. Let's solder them in. First let's measure the bridge rectifier, because although it gave us a nice thumbnail, I'd rather not blow up anything again. Measuring the bridge rectifier is like measuring 4 separate diodes as shown in this schematic. About 0.5 volts in one way and OL the other way. The bridge rectifier turns out to be a happy camper as well, so let's solder in our new replacement parts. First the MOSFET, then the thermistor, and finally the fuse. Alright, let's plug it in and see what it does. No fireworks this time, which is good, but no backlights either. Since we have no backlights, when we connect the power lead and the components on the power supply board all look fine, it might be the backlights themselves. Let's see what's going on with those. To access the backlights, we need to remove the front bezel of the TV by carefully prying it loose with our hands. Be extra careful around the PCBs connected to the LCD screen, they look a bit fragile. Carefully lift out the LCD. Remove these rubber support thingies. And remove these diffusers. Remove these whatever they are by turning them counterclockwise. And remove this last layer to finally access the LED strips themselves. There are clearly some caramelized LEDs here. Let's test which ones are broken. When we put our meter in diode mode, it will put enough voltage on the probes to test the LEDs. So one rail is fine, one rail has one broken LED and one rail has 3 broken LEDs. Maybe the current through the rail will get too high when 3 LEDs are missing, and in its infinite wisdom the TV decides not to turn on. Let's order new LED strips. Well, that's disappointing. They sent me the wrong strips. But last night I found a large Samsung TV standing on the sidewalk waiting for the garbage disposal. It's a nice one. The banana is for scale, but if by any chance you are a Bitcoin billionaire and want to buy it for $5 million, please send me a message. I'll give you a nice discount. After opening it up, I discovered that the mainboard was not present, so someone had a go at it already. But it still has a power supply board with loads of spare parts for the next TV I'm going to repair, and it has many LEDs on its strips. Let's use those to repair the LED strips of our current patient. Desoldering the LEDs is not possible with hot air from the top because that will damage the LED. So let's heat the board from the bottom. This does take a couple of minutes, but with a bit of patience we have our spare LEDs. Now to solder them onto our patient's boards, we remove some of the isolating layer, add some flux and add some solder. Then we heat the solder from the top with hot air, and as soon as it is melted, we put on the spare LED. And the previously broken LED strips are shining bright again. After connecting the power supply board, the backlights turned on and we have picture. So let's put everything back together. But first, let's leave some spare parts as a surprise for the next repair. What a nice way of saving this TV from the scrap heap. It was a lot of work, and replacement LED strips are not very expensive. So if you have the same problem, you might want to consider ordering a few replacement strips. but in this video we have proven that it is very well possible to repair LED strips if we want to. Thank you so much for watching. Please like and subscribe if you already haven't, and I hope you will join me in the next video. Bye then!